here at IIED. And of course, I can fail to wish you a very happy World Fisheries Day today, 21st of November. So just before we start, I would like to encourage participants to, if you wish to tweet, please use the hashtag FishNight6. That's one word, of course, FishNight6. 6 numerical. And let me ask my colleague Julia, sorry, just for quick health and safety instructions, please.
Yes, hi, welcome everyone. Yes, housekeeping person over here. We are not expecting a fire alarm or a fire alarm test today, so if there's a continuous alarm, just follow Sam or one of the IIED staff out that fire door upstairs and then onto the portal lane. There's a fire gathering point there. Wi-Fi, we've got our guest IIED Wi-Fi password on these boards if you need to connect for tweeting and social media posting. And then also for loos, the women's loos are just up this set of stairs here between the lower ground and ground, and then the men's loos are between the ground floor and the first floor.
Excellent, thanks so very much, Juliet. And now, without further ado, let me invite our Executive Director, Dr. Andrew Norton, to give us a few working remarks. Thank you very much.
Thank you so much, SM, and thanks for all your work to put this together. It's great to have you all here for the 6th Fish Night. SM asked me to say a few words of introduction. So, just some basic things. I'm sure most of you are familiar with, I guess, where we come from on this. In IIED, there's a strong concern with social justice. We have a work programme working with the least developed countries. Marine and coastal resources provide millions of people across the world with livelihoods, and that's very much geared towards the poorest people in the world. Of the 350 million who make their living from this, I think 90% are in developing countries. So the issue of social justice around this is something that's been very strong in the work programme that SM has developed. And of course there are a whole range of benefits from ocean and coastal resources, including flood protection, biodiversity, and nutrition. 1 billion people worldwide rely on fish as their main source of animal protein. So this critically important contribution for particularly the poorest people in the poorest countries is obviously under threat. These precious ecosystems are fast diminishing. The majority of fisheries are fished beyond sustainable levels. Coral reefs obviously degrading at a rapid rate. Those of you who will have seen the IPCC report on oceans and cryosphere recently, it's kind of the third in the trinity of reports mandated, in fact at COP21 in Paris, the 1.5 degrees, climate change on land and climate change in the oceans and the cryosphere. And they're all a tough read, but I think in some ways the oceans and the cryosphere is the hardest read of the lot. These are systems under just immense pressure at the moment, from climate change, but also obviously from pollution. SM's given me a figure that there are approximately 51 trillion microscopic pieces of plastic in the ocean, which is a big number. I won't compare it to anything. So to look at our contribution towards working on these trends, 6 years ago, before I joined as director, SM kicked off this work looking at issues that relate to social justice and inclusion, as well as sustainable management of marine and coastal ecosystems. So the work programme has looked at how we can use incentive-based management systems for sustainable management, but also the benefits for coastal communities. Using fiscal reforms to incentivise effective and inclusive management of fisheries. Looking at how we can understand the value of these precious resources in economic management and national accounts. And looking at also SDG 14 on the oceans and ways in which we can monitor and understand the progress we're making in that space. But also, finally, I mentioned the work we're doing in the LDC in the context of the BBNJ negotiations, the governance of the high seas. And I think that's a critical piece of work, because obviously it's an incredibly polarised sort of field of power relations. the 6 or 7 nations very much not wanting the high seas to be governed, and the LDCs are potentially a moral voice if we can help to facilitate that for the effective and sustainable management of the oceans. And Essam and his team have worked in that space and stimulated and done themselves some great work. So every year we do this fish night. It started before I joined. It's always a pleasure to be here. And this year we're focusing on the deep ocean. And there's this quote, we know more about the moon's surface than we know about our ocean floors. So tonight our speaker, Dr Diva Amon, will take us on a journey where we will be diving deep into the ocean to learn about the wonders of the deep ocean. Thank you very much.
Thank you. Thanks so very much, Andy, for the excellent sort of brief introduction about the work that we do here at IIED as well. So as Andy said, so tonight we're going to delve much deeper into the ocean. So we are very privileged to have amongst us Dr Diva Amon, who is a research fellow at the National History Museum. I'm sure Diva doesn't need an introduction, but let me quickly summarize her extensive bio. So Diva researches the weird and wonderful animals of the deep ocean and how our actions are impacting them. She has participated in expeditions around the world, exploring previously unknown deep-sea habitats from Antarctica to the Mariana Trench. During this exploration, she herself has ventured down to 2.6 kilometers below the ocean surface. She has recently spoken at the United Nations and the Nobel Prize, as well as filmed with the BBC and CNN, to name just a couple. So Diva, the floor is yours.
Thank you, Esma. Thank you so much to all of you for being here, and I'm going to try to bring fisheries into this a little bit, seeing as it is International Fisheries Day, but mostly I'm just going to tell you about the deep ocean and why I think it's an incredible place and why I also think it's a vulnerable place. As Essam said, my research tries to answer 2 questions. What lives in our world's deep oceans, which is what most deep sea biologists do, and also how our human impacts, what is wrong with me tonight? How we're impacting them, not just now, but also in the future. So to do my research, I tend to spend between 1 and 3 months at sea. We use a suite of tools, some of them sexier than others. This being one of the sexiest, submersibles, which are able to be our chariots down into the deep ocean, and they really give us a perspective that we wouldn't get any other way. We also work with remotely operated vehicles, which are car-sized robots, which we can send down into the deep sea to do our dirty work for us. These both sort of are our ears and eyes and hands on the deep sea floor. They have a suite of cameras, lights, manipulators that can be tweaked and customized. And really, we couldn't do our work without them. Of course, we use things like trawls and nets, cores that can take bits of the sea floor. But really, I count myself to be very lucky. There are very few jobs that allow you to be amongst the first people on the planet to see something, whether that is a new species, a new habitat, a new behavior, and every time we go down into the deep sea, that happens. So when I say deep sea, what exactly do I mean? Well, it's about from 200 meters depth all the way to the deepest point on the planet at just under 10,000 meters. And that's all of the blue that you can see on this map. And that's a massive area. It occupies about 60% of our ocean, of our planet's surface, and provides over 96% of all the habitable space on Earth. And that makes it our largest ecosystem by far. And it's vast, it's remote, and it's not an easy place to work. As you saw from the previous video, we need a lot of expensive technology, and all of those factors combined mean that the deep sea is really poorly explored and understood. And as the director said, you know, we actually have better maps of Mars, the moon, and Venus than we do our own deep sea floor. And that's a staggering fact. To make it worse, less than 1% of our oceans really have been explored. And by explored, I don't mean making a map, I mean actually visualized with human eyes or with a camera. And again, staggering, considering we're talking about our own planet. So it means that for all of this blue area, we can't really answer that fundamental question. What lives there? Much less questions like, well, what does this deep sea species eat? How old does it get? What role does it play in its ecosystem? And if we can't answer those questions, then how do we work out if we're impacting those species and those habitats? And if we don't know if we're impacting them, how do we come up with solutions? So because of that real lack of technology and exploration and understanding, for the first 100 years of deep sea science, we tend to think it looked a lot like this. This is a photo that was taken in the North Atlantic at about 4 kilometers depth. And you can see there's just not a lot going on, right? It's a bit boring, kind of barren. There's maybe one sea urchin there. But yeah, there's not really that much going on. And that's because the deep sea is a really difficult place to live. If I were to ask you to shout out 4 things that you can say the deep sea is, don't say wet. What would they be? Just shout it out. If you went down there now, what would you experience? Dark, exactly. There is no light, well, no sunlight past 400 meters. I heard pressure, someone said it. Cool. Extremely high pressure. So for every 10 meters you go down, you gain the equivalent of 1 atmosphere pressure, so what we're feeling now. So if you get down to this depth, 4,000 meters, it's 400 times what we're feeling now. So that's 2.
Cold.
Cold, exactly. So temperatures hover just above freezing, about 2 to 3 degrees. The last one's the hardest. So desert kind of pings onto it. Basically, there's not a lot of food in the deep sea. It's really food limited. Because there's no sunlight, that means there are no plants. And as a result, most animals in the deep ocean rely on the surface of the ocean for food. So that's where all the sunlight is, all the plankton, all the fish, all the life. And when they die, they drift down into the deep sea. And actually, that's where the majority of deep sea animals, like the sea urchin, get their food from. But improvements in our technology have really revealed to us in the last couple of decades that our deep ocean is actually not one big, dark, boring, homogeneous place. Just like on land, there are a variety of habitats. So in the top left, we have coral gardens. Coral gardens, over 2/3 of coral species are actually found in the deep ocean. Most people don't know that. And they're home to all kinds of other animals, like stick-gill sharks. In the top right, we've got lakes at the bottom of the sea. If you saw Blue Planet 2, you would have seen this. It's a brine lake. This particular one we discovered on an expedition I led in 2017 in the Gulf of Mexico. And basically, there's seawater that is 3 to 8 times saltier than the surrounding area. And that settles and forms this very surreal environment. And then in the bottom left, we have seamounts. These are mountains at the bottoms of the sea, and they essentially can just have a range of different animals on them. This particular one was explored by the Nautilus, which is a ship that streams all their exploration life. I highly recommend logging on if you can. And here, just in the last year, they discovered this seamount that had thousands of brooding octopus. That's what all these purple things are. And they're in their weird brooding position. This had never been seen before in the deep sea, these kinds of numbers. And you can see they sort of follow these fissures, it looks like. And what we think is happening there is that there's slightly warmer water coming out of those cracks. And the octopus think this is an optimum place for them to lay their eggs because the warmer waters might help to accelerate their development. So it's just a hypothesis for now, but it just shows the remarkable environments that are in the deep sea and really that we're still discovering things day in, day out. And because of this amazing variety of habitats, there's incredible biodiversity. They're thought to be about 1 million species in our oceans, 2/3 of which we still don't know, and most of those will be found in the deep sea. And the new technology that we have is actually allowing us to really see these species in a completely new way. So the video off to the bottom right was captured by colleagues, Steve Haddock and Mbari, and they used low light cameras, very sensitive cameras, to capture this sea cucumber, previously that was not known to bioluminesce or create its own light. And actually from the work that they're doing, they're now able to say that perhaps bioluminescence is the most common form of communication on the planet, given the size of the deep sea and the sheer number of species that probably use it. So, because life in the deep ocean, they have to deal with such difficult characteristics that it means that many of them have weird adaptations, right? And things that we tend to see are high rates of gigantism. Think about the giant squid or the giant isopod, which is basically a roly-poly like you get on logs that's like this big. Or we also see high rates of dwarfism, so animals tend to be very, very tiny as well, like streams. And then there are also, many of the animals have high tolerances to a variety of temperatures, chemical concentrations. But one of the most common traits that we find in the deep sea is that life is slow. Because of that lack of food, it means that animals tend to conserve their energy. Think about it, if you were starving, you wouldn't go run a marathon, right? So animals have slow metabolisms. They move slowly, they grow slowly, they reproduce not often, and they take a long time to get to sexual maturity and to get to really great ages. So to give you some examples, this top left is a Greenland shark, and they're known to live for up to 400 years and become sexually mature at 150 years old. Which, I mean, you should never ridicule anyone about when they lose their virginity. This guy takes it to a whole other level. And then we've got tube worms that can live for over 1,000 years. And then on the bottom, gold corals and black corals that can live for over 4,000 years. And then recently there was a discovery of glass sponges living for over 11,000 years. That's double the age of the wheel, okay? And I just want to stop and ponder that for a second. Like, one animal being around for 11,000 years. Think about the kinds of things that it would have witnessed. I don't know, it just blows my mind. But what I want you to kind of take away from this is that time scales in the deep sea are completely different to what you and I are used to. Essentially, things take a long time to get to maturity, to get to the way they are, and so they don't really deal well with change. And recovery is very, very slow. And because of our increases in technology and understanding, we now have a much better idea of how important the deep sea is to us. It is our largest ecosystem by far, as you've heard already. And that great size brings with it it performs these huge global functions and provides a lot of services to us. So for instance, it detoxifies our oceans by getting a lot of the stuff out of the shallows and taking it down into the deep, cycles nutrients around our planet. It regulates climate. Our oceans, as I'm sure many of you know, is one of the biggest buffers against the climate crisis. And that is unfortunately running out quickly. So I think the oceans have taken up 93% of heat generated from carbon dioxide emissions and 26% of all carbon emissions, of all carbon dioxide itself, right? So apart from that, we also have that the deep sea, something which is often underestimated, provides cultural value. It inspires us. Think about the amount of movies, I mean the Meg classic. But people do art about the deep sea. It really has this ability to inspire because it's so enigmatic, so unknown. But most importantly, our deep ocean more and more is providing us with crucial resources due to dwindling reserves on land and shallow waters. Today, if you sent a text message, you would have used the deep sea because that would have gone via submarine cables which lay across our ocean's floors. Also, it provides us with food, oil and gas. In the future, it could provide us with medicine. Antibiotic resistance is one of the biggest challenges that's going to face humankind, and we're looking for those new antibiotics in the deep sea. But then also, there's a lot of amazing genetic resources down in the deep sea, not just things like medicine. So for instance, a quick example, we're all being told to wash our clothes at lower temperatures, right, to help to use less energy. And now, or recently, because the deep sea is so cold, 2 to 3 degrees, animals that have enzymes that are accustomed to working most optimally at those temperatures. And so those have been extracted and incorporated into our washing powders. Now we're able to wash our clothes more efficiently at lower temperatures. So it's just one small example. But what I want you to take away from this is that some of the solutions to the world's greatest challenges could be found in the deep ocean. And we're only now really beginning to tap into that. But as with everything, there's a problem. Our use and our lack of care means that the deep ocean is changing. Those areas far from our coastlines, out of our sight, are not actually that far out of our reach. And the deep ocean, sadly, is no longer pristine. It has been a place of disposal for centuries, of fishing for decades, or extraction for decades, and now we are seeing the impacts of climate change already. And to complicate things further, as I mentioned, we now are thinking about getting other resources, things like minerals, from the deep ocean as well. So to give you a very poignant example of this, the video I'm about to show you was filmed in the Gulf of Mexico on that same expedition I led in 2017. And days earlier, we had found a shipwreck that no one knew was there, and no one had seen since the day it sank. It was an 18th century copper-clad merchant vessel, and it was just magnificent. And we had a second sonar target that was about 40 feet long and had the very characteristic debris field around it, which is like a classic thing for shipwrecks. And we were working in an area of the Gulf of Mexico that no one had been before, and let it going. And really, it was exploration in its truest sense. We were at about 2 kilometers depth. Everyone was huddled into the ROV control van. You could hear a pin drop. We had bets going about what we were going to find, how old it would be, what kind of ship. And really, we were all just in there holding our breaths, waiting to see what we found. And as we approached it, we were like, well, that looks pretty recent. That's definitely a very defined shape, metal. Okay, quite recent. And we realized the debris field was actually freezers, fridges, chest freezers, washing machines, dryers. And we found ourselves driving through a field at nearly 2 kilometers depth in a part of the Gulf of Mexico that no one had ever been, driving through a field of household white goods. It was very bizarre. And what we realized was actually the shipwreck was in fact a shipping container. 40 feet should have been the clue, but So the shipping container, which is actually quite a common occurrence, fell off of a ship, maybe in a storm or something, was ruptured and spilled its contents out onto the seafloor. And I can't really explain, but it was one of the most surreal experiences of my entire career so far, to be watching our trash on this scale, just scattered around this place that we hadn't been to. And unfortunately, on every single expedition I go on, from the Antarctic to the Mariana Trench, it's the same thing. Not necessarily on this scale, but it is pervasive. We see it everywhere. And again, it's in places that we've never been before. And yet, all of our evidence of us is there. And then, of course, there's things like deep sea fisheries. This is my one of 2 nods to fisheries for the evening. I'll say that it's bad for multiple reasons. Firstly, landings from deep sea trawling, it's always trawling, are minuscule globally. They occupy about 0.5% of all global fisheries landings. Secondly, it's bottom trawling, which is extremely destructive, as I'm sure many of you know. It clear cuts everything, takes out the structures that many of the fish rely on, takes out species that you don't want to catch, and also takes out young versions of the species that you want to catch. And of course, as you've heard already, many of these deep sea species are characterized by low reproduction, slow growth, not very often mating, blah, 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 and that makes them very vulnerable to overfishing, right? And so you get these boom-bust fisheries where, for instance, with orange roughy, classic example off New Zealand, they were fished and fished for several years, and then that was it. They were decimated and gone, and the fishery moved on to somewhere else. So the third bad thing about deep sea fisheries is that, which we now know from a study by Lizette Victorero that came out last year, is that catch levels were really poorly known. So poorly known that the bottom line of this graph is catch levels from the FAO, reported to the FAO, and then the line above is the FAO catches plus the Sea Around Us project, what they had estimated through a variety of mechanisms I'm not going to go into. But what you can see is that the new estimates suggest that the landings were underestimated by 42%, okay? And that means that essentially there's a systematic underreporting of what is being caught. And that means that fisheries managers are making decisions based on wrong information, which can have dramatic consequences, right? And what's most frustrating about this is that it's an extremely destructive fishing practice, and on top of it, the economic importance of these deep sea fisheries is minuscule. So when the environmental damage is not. So again, another way in which we're sort of wreaking havoc on the deep sea. And then of course there's climate change. Yeah, well, all just downhill from here, guys. So, as I said, the oceans take up about 93% of heat, 26% of carbon dioxide, most of that by shallow waters, but also by the deep ocean being that buffer. And it plays this massive role regulating our climate. But unfortunately, we're already seeing the impacts of climate change in the deep ocean. So, for example, we're seeing ocean warming, oxygen loss, increasing acidity, altered food supplies, all the things you get in shallow waters. And I was at a recent climate change workshop, and what we found is that by 2040, deep ocean conditions, so food, temperature, oxygen, pH, in this area of the Pacific that we're going to talk about shortly, called the Clarion-Clipperton Zone, will actually reach environmental levels that have not been seen for millennia, right? And that's bad. These changes are essentially going to change how life operates in these areas. It's going to change productivity, currents, result in decreases to food, smaller organisms. Again, all the classic things that you see in shallow waters will also extend down into the depths. And really, just as an example, or further example, that no part of our planet is immune from the climate crisis. And of course, to complicate things further, we're thinking of getting mineral resources from our deep ocean. Why? Well, all of us have a cell phone in our pocket or our bag, and those have about 60 different types of metals in each of them. On top of that, we have global populations increasing, standards of living increasing, economies developing. And then again, to make matters worse, we're now in this climate crisis, and we need to transition towards economies powered by renewable energy, and that needs batteries. Batteries need metals. So there's a lot that we're suddenly asking for, things like cobalt, nickel, copper, gold, and a potential place we're thinking of getting them is the deep ocean. And so there are three main deep sea deposits that are potentially up for mining in the future. They're each different in nature, in where they're found, and in the communities that live on them. And so first we have polymetallic nodules. They are sort of potato-sized lumps of metal that sit on the seafloor like cobbles on a street. And they're found between 4 and 6.5 kilometers depth in various parts of the world's oceans. And then we have polymetallic sulfides. Those are essentially hydrothermal vents, those really unique hot springs on the bottom of the deep sea floor that form these incredible chimneys and power really unique ecosystems. And they're found on mid-ocean ridges globally between about 1 and 4 kilometers depth. And then we've got cobalt-rich crusts, which are found on seamounts, those mountains at the bottom of the sea. And again, each different metals, but those tend to be found at between 1 and 2.5 kilometers depth. And as I just said, you can see that each of them really has different metals or key metals that they're being sought after for. But despite that, despite them being very different resources in very different places with very different communities living on them, the mining process itself will be broadly quite similar. So we'll have mining machines that move along the sea floor, removing the resource. That resource will then be pumped up to a ship that will be waiting above. that resource will then be dewatered on the ship, and all the wastewater will be pumped back into the ocean. And of course, this process is will definitely do a lot of damage. So we've got from the mining machines essentially destroying the habitat in a lot of cases. The minerals is the actual habitat that animals live on, as well as any life that's in the path of the machines. And then that mining process is going to kick up a huge amount of sediment and also tiny bits of metal. And that's going to form these big plumes, essentially sort of like dust storms in the deep sea. And those have the potential to spread for tens of kilometers horizontally and thousands of meters vertically, potentially. And then there'll be things like light pollution that animals aren't accustomed to, noise pollution, changes in sediment geochemistry, changes in chemistry of the water. And really what we can see is that the impact of mining will extend far beyond the mining footprint itself. And there are bigger knock-on effects. Second fisheries nod here, Sam. We think that because of these sediment plumes, for instance, that of course is going to rise up into the water column. For instance, the water that's being pumped back down, we have no idea at what depth that's going to happen yet. And that's going to cause a lot of changes in the water column. And of course, there's this huge global migration that happens daily with plankton and other animals. And that powers many of our fisheries worldwide. And so potentially this process, though seemingly quite small, could actually have these big impacts on things like fisheries that billions of people rely on. Also, there's going to be issues with potentially the ability of the seafloor to sequester carbon. If we remove a lot of the life, a lot of the bacteria that are responsible for that, will it change things? Will it alter our ability of our planet to regulate its climate? We don't know. But it's things that we really shouldn't sort of underestimate or forget about. And then of course, we may potentially, because of how little we know about the deep sea, lose species before we know them, which could be, of course, catastrophic. So where might mining take place? Well, there are two sort of forms of governments. Apologies if many of you know this, but you can see that there's black areas of the ocean and blue areas of the ocean. Black is obviously EEZs, exclusive economic zones, that extend 200 nautical miles from the shore, and those fall under the jurisdiction of that particular country. And then most of the ocean is in that blue area, which of course is international waters or the high seas. And all of the resources in this area are termed the common heritage of mankind. And that means that they belong to you and I, to everyone on the planet, to everyone that's yet to come. And so it's not really an easy thing to manage, right? So there's a body called the International Seabed Authority, an intergovernmental body related to the UN, that's been set up to manage all mineral resources in this blue area. And so far, they've leased 30 areas of seafloor globally for exploration as a precursor to mining. So up here on the right, we've got polymetallic nodules, the lumps. Then in the green, in the center of the Atlantic and off of the coast of Africa, we've got hydrothermal vents or polymetallic sulfides. And then off to the far right in orange, you can see that's where the seamounts or cobalt-rich crusts have been leased. And now this may seem insignificant, but each of these 30 leases can be the size of Sri Lanka, 75,000 square kilometers roughly. And if you think that actually this is what the entire global resource, we think, of these minerals looks like, even though those are the leases that have been granted now, there's the potential for this to amplify in a very, very real way. And perhaps deep sea mining, if not done responsibly, it could be a massive change for our ocean, could prompt a lot of impacts. So to zoom in on that red area that was over here, the Clarion-Clipperton zone, just to give you a quick feel, there have been 16 leases granted in this area. It's a massive area, the size of the contiguous US. You can see Hawaii, Mexico off to the right. And each of those colored blocks is a contract area that has been granted to a country or a company sponsored by a country. So the UK, for instance, has those two light blue ones, the one in the center and the one off to the right. Singapore, France, Germany, China, there's a lot of countries that have them, as well as a lot of developing countries like Kiribati. And right now there aren't any rules and no mining's happen, but it's working towards that. So to quickly tell you a little bit more about the actual environment, This is the Clarion-Clipperton zone, and you can see those lumps on the seafloor. Those are the nodules. And this area, I did work at the University of Hawaii from 2013 to 2016, and we worked in the UK least area. And that was the first time that anyone, science or otherwise, had been to the deep sea floor in that area. And what we found amazed us. Essentially, it's turning out to be one of the most biodiverse places on the planet. There are over 1,000 large species in a 30-kilometre by 30-kilometre block. And of those 1,000 species, 90% of them were new to science. Okay? So what was most frustrating is that more than half of the large species, like the anemone you just saw, rely on the nodules themselves. They use it as an anchor to attach to, and without those nodules there, they likely will not survive. And so things like corals, things like anemones, things like sponges, they are absolutely reliant on these nodules. So mining may have a very big impact. And don't share this slide, obviously, because there's unpublished stuff there, but our discoveries in the CCZ are not just limited to the deep sea animals down there. We're also finding things like whales, the most conspicuous animals in our ocean, use this area extensively as well. We found a number of whale falls, which is when the whale dies, drops to the sea floor, forms this massive feeding bonanza. And then a colleague, Lee Marsh and others, found a couple of years ago these sort of gouges on the seafloor and traces. And what we think is happening there, and this is at over 4 kilometers depth, what we think is happening is that beaked whales are diving down to the deep sea floor for some reason and running along the seafloor, making gouges, whether it's to feed, to slough off parasites, we're not sure yet. But if that was the case, that would extend the record for deep diving animals or deep diving mammals by over 1 kilometer. So it would be a phenomenal thing. And then off to the right, we have, and this is the unpublished bit, we've discovered beds of fossilized whale bones and shark's teeth in this area. A lot of them, and a huge variety of them. And it shows that whales have been using this region for millions of years, potentially up to 16 million years. And we've never seen whale fossils or any fossils other than coral fossils like littered on the seafloor like this. And so it could be a place also of paleontological significance. Now the second resource is our polymetallic sulfides at hydrothermal vents. It's this area where superheated metal and chemical-rich fluid gush from the seafloor, powering ecosystems in the process and building these incredible chimney structures. That is not actually smoke, it's superheated fluid, full of metals, and many of the animals living at these environments are found only at these environments, over 80% in fact. And they have a lot of unusual adaptations. They use chemosynthesis, so chemical energy, to make their food, and they provide us with clues to how life evolved on this planet, and potentially how it may have evolved on other planets as well. And so this particular vent you're looking at here was discovered on an expedition I led in 2016 to the Mariana Trench, and before this was filmed, no one had ever seen it. And it's 10 stories tall, okay? And so this is not a small thing, but it shows that these are places we are still discovering. And finally, the third resource, cobalt-rich crusts from seamounts. You can see the crusts, that black thing coating the sea floor. That's what holds those very valuable metals. And because these are mountains that extend off the sea floor, it causes the currents to circulate around them, we think, trapping nutrients, resulting in a lot of life. And this imagery is from the West Pacific, where the most valuable crusts are found. But because of that large amount of nutrients, we get a lot of life. And a lot of corals, a lot of sponges, what we call rainforests of the deep sea. They're like trees, they have that three-dimensional structure, providing life to a lot of other species. And as you heard, they can get very, very old. We know a lot about these environments, but not enough. So our lack of understanding really also extends to how these ecosystems will cope with the impacts of mining. There have been very few tests done, none on the scale that deep sea mining may occur on, but this one was a much smaller event where a trawl was essentially dragged along the sea floor in the Clarion-Clipperton zone or close by. You can see the nodules on the floor. And if this were to be done in, for instance, a field, as it is done with a plow, this would take perhaps a couple of months to get back to the way it was. maybe at most a year, but really not very long because of wind and other processes. But this track you can see here is actually 26 years old. And it shows that, you know, change again is very, very slow. Recovery is very, very slow. And what's most frustrating is that these nodules, they form like a pearl does. And they basically accrete metal over a very long time, about 1 millimeter thickness per 500,000 years. So this is not a renewable resource, right? And so this kind of environment is not going to recover in our lifetimes, in our children's lifetimes, in our grandchildren's lifetimes, not in our timescales at all. I'm wrapping up. So the deep sea, what I hope I've convinced you of is the deep sea harbors not only valuable resources, but also unique biodiversity and habitats. And every time we look, we find species that amaze us. The deep sea pushes our boundaries. It really breaks paradigms of life. And many solutions to some of our challenges could be found in the deep ocean if we keep looking. There's a lot to grapple with. Is it better to extract from the depths of our ocean, where very few of us go, rather than the places that you and I interact with on a more regular basis? Should we be exploiting places that we don't yet understand? How else do we solve the climate emergency? And potentially, could we be creating another planetary crisis to avert another one? These are questions that, of course, are not really difficult to answer, and I can't answer them, but we need to if we're going to manage our oceans responsibly and help to preserve them for generations to come. So I'd like to leave you with a quote. Pliny the Elder, a Roman historian, naturalist amongst other things, and in 77 AD-ish, he said, "By Hercules, in the sea and in the ocean, vast as it is, there exists nothing that is unknown to us." And of course that was about 2,000 years ago, and at this point deep sea exploration really hadn't begun. And this is the exact kind of mindset that we need to absolutely not have. Our deep ocean is amazing, important and vulnerable, and it has a lot of secrets still to give up. And it's only by getting, again, that better understanding can we be able to manage it more effectively and preserve it, potentially, for generations to come. Thanks.
Well, thank you very much, Diva. Shall I sit down, or how does this work?
I feel weird to sit if you don't
Let me sit down, okay. No, I think when we first started organising fish night events at IIED, there was a question, why should we do this? And the consensus in the room was that because we want to inspire each other, we want to create a space for people to come together in one room and go get inspired and go and find a solution like that. And I think that was the definition of inspiration. I think you've done a fantastic job, honestly. It was fantastic. I think by far maybe the best.
I'm just glad you managed to put a spotlight on the deep ocean.
Right.
It's important.
It is very important indeed. And I think I should have introduced myself from the very beginning. My name is Esa Muhammad. I lead the this work program on blue economy. So we're going to open the floor for Q&A, but just before we do so, I have a couple of questions for you, Diva. I don't think many of us in this room have had the opportunity or the chance to go that deep into the ocean. And pretty much the same thing that people would have when they go to the moon. And my question is very simple. How does it feel when you're there? Especially when the first time you went there, let's say about 2,000 meters below sea level. You know, all those emotions that go through your minds.
A lot of emotions. You're thrilled. I mean, this is something that a lot of us dream about.
Right.
And to be able to get that opportunity really is a privilege.
Right.
But I know people want to say that, you know, you're terrified. That exists for like 5 seconds.
Right.
But really, the overwhelming fear is that you're in this submersible for 9 hours and there's no toilet. So yeah, there's a lot of mechanisms to get around that, but that is really what is at the foremost of my mind most of that time. But apart from that, I mean, you're afraid for probably, you know, the first 5 minutes as you're going into the water, because if something were to happen, realistically, no one can help you.
Yeah.
But you're excited.
Excellent.
You're going to see things that no one has seen before. And on top of it, you have, because they can only hold like 2 to 3 people, you have a shopping list from all of your colleagues who were left on the ship.
Right.
And so you have this big to-do list that you have to get through in the 5 hours you're down there, right? Because it takes a while to go down and a while to come back. And you just kick into what you are accustomed to doing, which is, you know, science and getting it done.
Excellent.
And then before you know it, it's done.
Excellent. That's fantastic. I guess my next question is going to be, is half serious, not so serious?
That was a really serious question.
Right. No, because you said you spend about 9 hours in submersibles, and it's very interesting. I think if I remember anything from my lessons in marine biology, if you spend more than 20 minutes, I mean, deep in the ocean, apparently it does diminish your cognitive performance, which entails
This is news to me.
This is scientific fact. You know, it does impair your thinking, your reasoning, and your problem-solving ability.
But it,
etc. And how much of what you just told us should we believe?
I will say that I'm going to assume that means for scuba diving, when you're obviously your body's subjected to those pressure changes. But in this case, our submersibles are exactly normal pressure, if not a little bit lower. So really, like, you can get out of it and get straight on a plane.
Right.
It's more or less, you feel more or less normal.
Okay.
I have heard about pilots altering oxygen levels if someone's talking too much or something.
Great. So I think then we can believe whatever we were told by people just And now, on that note, let me open the floor for a couple of questions, or 3. Where I see a couple of hands already, so please there. And if you can introduce yourselves as well and ask a question.
Cool. Hi, that was amazing. Thank you so much. You managed to sort of show us how incredible life is down there, and also just how much danger it's in, which we all should know more about. I am currently struggling to follow the progress of the High Seas Treaty being done by the UN. You'll know, and it's pretty much just like whether you can shed any light on it and what it might mean for deep sea protection, because I don't know what's going on.
That is a great question, and actually one that I feel you are better to answer, because the sound goes to every single one, whereas I've only been to a couple. What I'll say is that and it's very, very short, is that I think whatever the outcome is, will be hugely, what's the word I'm looking for? Consequential, sure, that's not what I was looking for, but that works. For how our oceans are managed in the future. And I think things are progressing, but very, very slowly. And Sam and I were actually talking about it. It's a bit like a soap opera, right? Like, you get to know the characters, people have their own geopolitical ideas, and really it's intergovernmental processes are confounding, biased, but we need to work with what we have. And it's going to be a long process, but yeah.
Sure.
Shed some more light.
And of course, I would be more than happy to do that.
Was really waffly.
Yes, that's always it's really great, spot on. So, with respect to the high seas negotiations, or what's termed as the BBNJ, so with respect to the deep sea, there is slightly very interesting issue that we need to look at, because Diva characterized all those minerals that are found in the deep sea as a common heritage of mankind. That's according to the UN Convention on the Law of the Sea. What's interesting is all those living things that we saw that are living in the seabed, on the rocks, on the nodules, etc., are not labeled or recognized as common heritage of mankind. So when you look at international law from the Law of the Sea point of view, while those nodules, those rocks that we saw, the seabed surface, etc., is the common heritage of mankind, while those organisms, living things that live around them, are not part and parcel of the common heritage of mankind. And that's one of the divisive issues with respect to deep seabed in the high seas negotiations, is that there are a majority of countries, primarily developing countries, who advocate in favor of recognizing all the creatures on the seabed as a common heritage of mankind, and you have the most powerful nations, particularly those who have the financial and technical ability to go and exploit it, who say, no way, there is no way that you can label those resources as a common heritage of mankind. So that's one of the thorny issues, and if there's anything that's going to be dragging us back from moving forward in this negotiation, that's going to be it.
And to add something to that is that the International Seabed Authority, which I mentioned, they're going through their regulatory process right now as well, and that's happening side by side with the BBNJ negotiations. And there's not much overlap between them, even though there absolutely needs to be, because we're talking about very, things that operate in the same space. So no one's really dealing with that yet, and I think a lot of that's purposeful, but it is going to have to be dealt with, and that's again going to be a very, very problematic issue later on.
Thank you, Diva. Shall we take a couple of questions?
My name's Andrew. That's quite inspiring. Thank you. My question is, you kind of showed that you've got unpublished work that you've got upcoming, but I'm interested to know what you've got next, what sort of projects or research, if you're able to share, expeditions that you foresee.
So I'm currently on a European Union fellowship, which runs out in March. And so from now until March, I'm basically just trying to pump out as much research as possible. And that means just sitting in a room trying to write. One of the papers is on fossils, which we're going to be working on. There's one on deep sea debris. There's a couple of species descriptions from the deep ocean. And then after that, I'm going to be continuing to, a big part of what I do is not just research, but also science communication and also policy work. And so I go to the International Seabed Authority every year, twice a year, to help inject science into those negotiations, and that's something that's going to be happening next year again as well. And also potentially working with a couple of organizations to again try to inject science from a different route. That's sort of wishy-washy, but I can't say what it is yet. And then I'm going to change tack slightly, which maybe isn't what you were hoping for, but I'm going to do a bit more science communication. So there's a potentially like quite big TV series that I might be working on soon. So watch the space. Watch the space. So I like doing all three, and it's giving me a chance to now test my waters purely in policy. I've done pure research, now I want to test pure policy, and then I want to test pure science communication.
Excellent.
And then see again if I can bring them all together after.
Terrific. And of course you've received that award from the
Seabed
Authority.
We don't need to talk about that.
That's wonderful. Right. That's fantastic. Shall we take a couple more questions?
You can
Sure.
go first.
Okay, sorry, I have two questions. The first one is, maybe there's no answer because you said things move slowly, but are there any interesting migration patterns of sea life due to the changes which are taking place? And secondly, this is quite a different question, but I think, you know, we're very exposed to what's happening like on Earth. So for example, rainforests and stuff like that. And there's a lot of private sector support as well as the UN, and I think that together is really like bringing public awareness and changes. So is there any kind of private sector support for the deep sea, or is there any awareness being raised which isn't the UN, because sometimes I feel like change doesn't happen fast enough. So what was the first question again? Migration.
Right, migration, right. So unfortunately, I'm sure there are. I mean, of course we know about the daily migration of plankton and other things, but in the deep sea specifically, because we actually can't say what lives in most of the oceans, like we actually don't know that, it means that we struggle to understand things like migration patterns. And so I'm sure there are, but we just don't know about any yet, unfortunately. What we do know is that a lot of animals use the deep sea floor and then also use the shallow waters. For instance, like animals will send a lot of animals that live at hydrothermal vents send their larvae up into the surface waters, and they are then transported by currents there and then drop back down somewhere else. So we are beginning to understand things like that, but actual migrations of mature animals, we just don't know yet, but probably. Second question, private sector. there's a couple of things. Firstly, I think the deep ocean is largely out of sight, out of mind. People don't really give it much thought. The oceans really are having a heyday now, so hopefully that will mean that the deep ocean gets a little bit of that. But really, it sort of falls by the wayside a lot. But there is some private sector support. But more what we're seeing now is there's a lot of philanthropic support. So there's like quite a couple billionaires who just have partly, I mean, they do this for multiple reasons, I'm sure, but they have ships that they give to deep sea scientists to use with submersibles. For instance, that one that you saw in the video, that's owned by Ray Dalio. And yeah, they're great platforms for scientists to use research. So a lot of philanthropic stuff, a lot of NGOs working in that space trying to raise awareness. And then of course there's industry, but that isn't necessarily, that's now getting going, I think. But yeah, I hope that answers your question.
Excellent. So I'm going to take one more question.
Yeah. I was just wondering if there are any alternatives to deep sea mining that people have researched which would be potentially better alternatives that you know about. Or...
So I'm not an economist, but if that wasn't apparent. And I can't speak to like the hard numbers, but there is this big push that, you know, the circular economy is where we need to be thinking about. Refusing, reusing, recycling, it's all things we hear about all the time, but actually that could be, a lot of metals right now are just thrown away and aren't ever used again. And perhaps we should be thinking about getting metals from those places in the future. But whether it will be enough to sustain what we need, we're not sure. So actually there's a lot of discussions happening, for instance, at the World Economic Forum and other places with big battery operators that, you know, if you start at the beginning and try to phase out those metals from the batteries, that's potentially where the biggest gains will be made, rather than trying to.
Sure.
Yeah.
No, I think that's a very good question. Actually, one of my questions is going to be related to that, because particularly with so much drive, I mean, transition from fossil fuel powered automobiles, for instance, and using electric cars, which will require, of course, you know, an awful of cobalt, at least in the batteries, etc. So people are looking at, you know, deep sea resources to enable that to happen. But of course, there's an awful of people in countries who are saying, wait a minute, I think we need to understand it better. As you rightly said, we know only 1% of the deep sea now. And from what I know, a couple of countries such as Fiji and Papua New Guinea have called for a moratorium, but just for 10 years. And from what you just told last night, 10 years seems to be an overnight, like in deep sea terms.
I think a lot of people hope that, you know, with, for instance, we're beginning the UN Decade of Ocean Science next year. And I think a lot of people hope that, again, the oceans are in this heyday, and that 10 years there'll be a lot of research that potentially points to the fact that actually this isn't such a good idea. But I think, I'm not going to tell you which side of the fence I sit on, it's pretty obvious though, but I think on the flip side, while Vanuatu, Fiji and Papua New Guinea are calling in for a moratorium, as well as a lot of other countries, not Pacific Islands, there are many developing countries, or I know that's not necessarily the best word, but Pacific Island nations, for instance, like the Cook Islands and Kiribati and Nauru, that actually do want deep sea mining to happen because they have very limited resources, and potentially the blue economy could be a place for them to sustain themselves in the future. So, yeah.
Right, okay. So with everyone's permission, I think, is it okay if we take maybe 2 or 3 more questions before we go upstairs and we have a wide range of cold beverage there?
And I'll be there for if you want to ask more questions.
So let me take a question, one from the back and one from the front. So please.
Thank you very much.
Shall we take the questions at the same time?
What? Oh, right.
Sorry, long day. So, 2 questions, but we don't respond. Right, please,
Yeah, thank you very much. My name is Rebecca Lyle, and I was really interested about the slide with the beaked whale, where the potential gouging. I was wondering if there's any what kind of led you to that conclusion? Any features in the area or behaviour you've seen in other beaked whales where they've done the same gouging behaviour?
So I'll say that it wasn't my research, it was a colleague, Lee Marsh, as well as a couple other scientists. And I think that phenomenon has been known for a while. Like for instance, Bob Ballard, who rediscovered the Titanic and other things, hydrothermal vents, he noted them like decades ago in his writings. Whether anyone has actually seen them doing it, I'm not quite sure. But the fact that they were in these sort of very distinct tracks that went for, you know, hundreds of meters, really did point to that could be the only thing. But because, interestingly, because the deep sea takes us such a long time, as you saw from the plow marks, to get back into place, to reshape, I guess, the deep sea floor, they think that a lot of those gouges could be really old, like thousands of years old, kind of thing. So it probably is actively happening still, but also some of those are probably sort of remnants as well. But I do encourage you to read the paper. Just Google Marsh et al. 2018, like whale deep sea diving things. You'll find it. It's a great paper.
Let me take one more question on this side.
Hi, my name is Tara. Thank you so much. It was an amazing presentation.
Thank you.
Really inspiring. So I was really interested in what you had to say about the really, really old species, like the ones that can last hundreds or even thousands of years. And so you mentioned that they're really vulnerable, but the fact, it kind of struck me that the fact that they've lasted for so long also shows their resiliency.
Yeah.
Because I mean, they've been around for a lot longer than our whole
You and
entire
I,
economy.
yeah.
So is there any sort of future study looking into this kind of mechanism of this resiliency, because they've been going through so many different changes in climate, and then like, are we like kind of looking into tapping into that and like knowing more about that?
Oh, I think
or
that
is it just like a chance, like they've just never been touched?
So I think it's mostly the latter, in that the deep sea is a really stable place and just doesn't really experience change very often, and so they're just fine to keep plodding away as they have been for thousands of years.
Yeah.
But as I said, there are a lot of these animals have a lot of genetic properties which could be very useful, and so I think there is definitely incentive and drive to understand why they're able to do this and potentially use that in some way. But we don't actually know how old most deep sea animals get. Like, perhaps there's maybe, I don't know, definitely not even 100 species do we have ages for. And that's just the kind of level of knowledge that we're really just absolutely missing. So we know for some species they get really old. That's probably the case for a lot of them. But really, well, I'm generalizing massively because we don't actually know how old many of them get.
Can I just ask a supplementary?
Sure, please.
So how do we know that these creatures look
Right, so it depends on the species, quickly. Greenland sharks date something in their eyes.
Yeah, so it's like an eye.
Exactly. Corals, you use their base, and
so
it's
this
almost
is
like
a
a
tree.
exactly like a tree ring. Exactly. And then I think with like bivalves or mollusks and other things, they've been able to date the shells, but really that's kind of where it stops. We have no idea how old most animals get.
Yeah.
Much like just basic things about their biology. Just no idea. Yeah.
Yeah. Great. Diva, I'm sure a lot of people would have many questions, but I'm sure we can do that sort of in a more relaxed and
wine.
Exactly, glass of wine upstairs. But I think what we've learned tonight is the fact that there's so little that we know about the deep sea, and definitely I think we need to enhance our understanding in deep sea biology and resources, etc. But also I think it's very important that we step on the brake pedal with respect to deep sea mining as well, and I think
or just all deep sea extraction.
Right, exactly. Yeah. Right, so I think that's been extremely inspiring, very insightful presentation, and great questions as well.
Yeah.
Ladies and gentlemen, Diva Amon. Just before we go up, I would like to express my heartfelt gratitude to the team, who worked so hard to make sure this runs very smoothly, this event, and but they're all standing at the back. So we have Anne and Juliet and Geraldine, Zayza, Ehenia, Annabelle, Matt. The list is very long, but thank you so very much.
Before everybody heads upstairs,
Yeah.
I would like to remind them about IIED's podcast,
Okay.
which the first episode features Assam talking about the ocean.
So you have to skip that one.
You can find it on all your favorite podcast